Solving a 3 by 3 system using Gaussian elimination. We are going to solve the following system. 2x minus y plus 2z equals 10, x minus 2y plus z equals 8, 3x minus y plus 2z equals 11. Our first step will be to write the augmented matrix. That means I'm going to go through each equation in standard form, so x, y's, and z's on the left-hand side, constant on the right-hand side, and we're going to write the coefficients in a matrix. So 2x, separate the 2. For the minus y, I write -1, plus 2z, I write 2. I'm going to put a little line to show where I'm writing my right-hand sides, although this is not a necessary step, it just helps make it more readable. And then on the right-hand side, I have 10. For the second equation, for x, I write 1. For -2y, I write -2. Plus z, I write 1. And on my right-hand side is 8. My last equation, 3x, I write the 3. Minus y, I write -1. Plus 2z, I write 2. And my right-hand side is 11. This is my augmented matrix. We'll refer to this first row as row 1, row 2, and then row 3 is the third row. And my goal when using Gaussian elimination is to end up with a matrix where I have a 1 as the first element in the first column in the first row. I have numbers, and then another number. Then I have a 0 under the 1, and my second row, second column element is a 1, and the other numbers are just whatever numbers they end up being. And my third row looks like 0, 0, 1, and then I have a number on the right-hand side. So this red matrix is what I want to turn my current matrix into using row operations. This is called row echelon form, or our calculators refer to it as REF form. So you'll notice that the diagonal on the left-hand side, we have 1s, and we have this blue triangle of 0s underneath that diagonal of 1s. That is row echelon form. We can use the following row operations in order to transfigure our starting matrix into row echelon form. We can switch any row. We can multiply a row by a constant. We can add one row to another, or we can do combinations of these, like multiply a row by a constant and then add it to another row. Okay, so this is our starting matrix again. I just wrote it on the second slide so we can see where we are. We now want to get a 1 in row 1, column 1. So right here, this 2, we want it to be a 1. I could switch rows 1 and 2 without having to do any other math in order to accomplish this. So if I switch rows 1 and 2, my row 1 will now be 1, -2, 1, 8. My row 2 will be the 2, -1, 2, 10. Row 3 stays the same as 3, -1, 2, 11. Okay, so I've accomplished my first goal of getting a 1 in row 1, column 1. Next, we want to get zeros below the 1 in column 1. We want this 2 and this 3 to be turned into zeros. So what I'm going to do to row 2 is to multiply row 1 by -2 and add it to my old row 2. So my row 1 will stay the same, 1, -2, 1, 8. But row 2, I'm going to multiply my row 1 element, the 1, by -2, and add it to my old row 2 element of 2. So -2 times 1 plus 2 equals 0, and that will go in underneath the 1 in column 1. For my second item, I do -2 times -2 plus -1, and I get the 3. And now I'm taking the row 1 element in column 3, which is the 1, I'm doing -2 times that 1 and adding it to the old row 2 element of 2 and getting 0. So 0 goes underneath the third one. And then on my right-hand side, I'm doing -2 times 8 and adding it to the 10. I get -6. Okay, for row 3, in order to turn that 3 into a 0, I will create row 3 by multiplying row 1 by -3 and adding that to my old row 3. So -3 times 1 plus 3 equals 0. -3 times -2 plus -1 equals 5. -3 times 1 plus 2 equals -1. And -3 times 8 plus 11 equals -13. So this is my resulting matrix after those row operations. So I have a 1 in the first row, first column, and then zeros underneath that 1. Now I want to make a 1 in row 2, column 2. And I can do that by multiplying row 2 by 1/3. This 3 will be turned into a 1 by multiplying the entire row by 1/3. So my first row stays the same because I'm not changing that. So 1, -2, 1, 8. For my new row 2, I'm multiplying all the elements by 1/3. So 1/3 times the old 0 is still 0. 1/3 times the 3 gives us the 1 that we need. 1/3 times the old 0 gives us 0. 1/3 times the -6 gives us -2. And row 3 will remain the same. 0, 5, -1, -13. Okay, so now this is our resulting matrix. I've got the 1, -2, 1, 8, 0, 1, 0, -2, 0, 5, -1, -13. Our next step is to make a 0 below the 1 in column 2. So this 5 needs to be made into a 0. I can do that by multiplying my row 2 by -5 and adding it to my old row 3. So in my matrix, row 1 stays the same, 1, -2, 1, 8. Row 2 stays the same, 0, 1, 0, -2. But my new row 3 is found by multiplying my row 2 elements by -5 and adding it to the old row 3 elements. So -5 times 0 plus 0 is 0. -5 times 1 plus 5 gives me the 0 I need. -5 times 0 plus -1 gives me -1. -5 times -2 plus -13 is -3. Okay, now we need to make a 1 in row 3, column 3. Okay, we're almost there because we have a -1. So we can make that a 1 by multiplying row 3, every element in it, by -1. Okay, so our new matrix, row 1 stays the same, 1, -2, 1, 8. Row 2 stays the same, 0, 1, 0, -2. Row 3 we get by multiplying our old elements by -1. So -1 times 0 stays 0. -1 times 0 stays 0. -1 times -1 makes a +1. -1 times -3 gives us a +3. So here is our row echelon form matrix. 1, -2, 1, 8, 0, 1, 0, -2, 0, 0, 1, 3. Now, in order to get the solution to our system, we'll use back substitution. Remember, when we created the augmented matrix, we read the coefficients from the equations. Now we can go backwards and read the equations from the coefficients. So this last row is 0x plus 0y plus 1z equals 3. Or in other words, the zeros go away, and I just have that z is equal to 3. The second row becomes the equation 0x plus 1y plus 0z equals -2. Or in other words, with the zeros going away, y equals -2. In some cases, not this case, we would have had an equation with a z as well, where we would have had to substitute the 3 in for the z to figure out what y was. Here we did not. Our last equation is 1x minus 2y plus z equals 8. So here, in order to figure out x, we do need to use some substitution. So we're going to substitute -2 in for y, and we're going to substitute 3 in for z. So this equation becomes x minus 2 times -2 plus 1 times 3 equals 8. Or x plus 4 plus 3 equals 8. Or x plus 7 equals 8. Now if we subtract 7 from both sides, we get x is equal to 1. So now we have a solution for x, y, and z. X equals 1, y equals -2, z equals 3. And this is our solution. We often write this as an ordered pair with 3 numbers in parentheses separated by commas. So I put my x value 1 first, comma, my y value -2, comma, my z value 3. And that's my solution to the system, 1, -2, 3.